through 9. So first, let's read the problem statement. It says, in a boat race, boat A is leading boat B by 50 meters, and both boats are traveling at a constant speed of 183 kilometers per hour. At times t equals 0, the boats accelerate at constant rates. Know that when B passes A at 8 seconds, the velocity of A is 225 kilometers per hour. So first we have to convert the units of kilometers per hour to meters per second. So in order to do this, we do 183 kilometers per hour. We know there is 1,000 meters in 1 kilometer. Then we know there's 1 hour. There's 60 minutes. And there is then we gotta convert to seconds. So in 1 minute, 60 seconds. So then we get, this is roughly about 51.66 meters per second. That's for both. Okay, then now we do BA equals 225 kilometers per hour. And we do the same multiplication, multiplying, convert the units. Get roughly about 62.5 meters per second. Now we convert the units. We use the basic equation of motion where the velocity of A equals initial velocity A plus acceleration of A times t. So in this case, we know this velocity A after 8 seconds, so we know the time as well, and then the initial velocity as well. So we just plug in the numbers and solve for A. So we get acceleration A equals, first do it in terms of variables, then we plug in the numbers. We get BA minus BA initial divided by time. So plug the numbers, we get the following. We get 62.5 meters per second minus 51.66 meters per second divided by 8 seconds. So we get 1.354 meters per second square for the acceleration of A. So now we're trying to find the acceleration of B. So have to come up with a relationship for both of them. So we know in terms of displacement, because this is a common between the two of them, we know displacement time it takes to reach the boat. So if we do another equation of motion, should be XA initial plus the initial velocity times time plus 1/2 acceleration of A times t squared. So we know the time on all of these. So let's see the knowns and unknowns. You know these, you know these. Now let's do same for B. So XB, we know XP initial, and we know plus BP initial times T plus 1/2 AB T squared. So if we have, this is the unknown we're looking for, we know the time, we know the initial, we know the time, this, so we know the final displacement, so initial displacement, final displacement, so we know the final displacement, XA, XP, they're the same. So if we have this relationship, we set up equals to each other, and we solve for AB. So we're trying to find the acceleration of both B. So let's do that in terms of variables first. So XA naught plus BA naught times T plus 1/2 squared equals 3 naught plus AB naught T 1/2 AB T squared. So I'm gonna solve for this one right here. So we get AB equals, so like this, copy paste, minus x naught minus BB times T. All of this multiplied by 2 divided by T squared. Plugging in all the numbers, we get that this equals, it's roughly around 2.920 meters per second squared. That's it for this problem. It's just basically looking at the relationships and equations of motion. So make sure to remember this equation. That's one of the equations for motion. And this is another equation that relates. So look at the knowns and unknowns. This relates velocity, acceleration, and time. So no displacement involved in this equation. And this one over here, we have displacement, velocity, acceleration, and time. So this is more complete and involves a lot of components, while this one disregards the displacement. So depending on the knowns and unknowns, you know which equations to use. So that's it for this video.